Josh, we're rolling. Oh my God.
Hey everyone, and thanks for joining us today.
Today we will be taking a closer look at position, velocity, and acceleration over time.
Alright, let's take a closer look at position. Watch as a particle begins and stops at a different distance over time. It's time to take a closer look at velocity. Notice as our particle is traveling at a consistent speed over the given interval in the same direction. Alright, it's time to take a closer look at acceleration. Let's accelerate this particle. Notice as the velocity is increasing over the same interval in the same direction.
And next we'll be looking at position, velocity, and acceleration graphs and how to maneuver between the three. Alright, now let's get started. To start out, as you can see, the slope of the position graph is 1. Alright, and to move to velocity, you need to graph the slope from the position graph, and since it's 1, we'll graph it at 1. And to move from velocity to acceleration, you're going to graph the slope of velocity. And as you can see here, that slope is 0. So on the acceleration graph, it will be 0.
Alright, so in this instance we're going to start out with our velocity graph. So if you look closely here, wherever you have a slope of 0 on your position graph, that essentially reflects wherever you're going to cross the x-axis on your velocity graph. So if you look between the units of x equals 1 and 2, we have a slope of 0, so you're going to cross the x-axis right there. We have another one between x equals 1 and 2, which is right there, and then one more time at x equals 4, which is right there. And then as far as the acceleration graph goes, like Josh earlier said, it's just a graph of the slope of the velocity graph. But another way to think about it is, because you're going to have to be drawing between points, is that look at the way your position is changing. So we have a curve here, so yes, your value of position is increasing, but it's doing so at a decreasing rate, as reflected between these 2 points of 1 and 2 on the velocity graph. So how do we reflect that in acceleration? Well, it's essentially a negative acceleration. So once again, that's the slope of your velocity, and that's also showing this decreasing curve in your position graph. And you see that once again in this curve where we're actually beginning to increase. So we see our velocity increasing with that curve here, and then we have a positive value for acceleration.
Alright, we got a new graph this time. Let's start with the acceleration graph. So as you can see, this is negative, which means the velocity will have a negative slope. And since it's crossing the x-axis, it will be changing directions. And then as you can see, it gets flat right here, which means it will be staying at that same velocity until it moves upward, as you can see here. And it is slowing down, but it is still negative. And then you can see it moving up, and since it's crossing the x-axis again, it is changing direction again, and the velocity is increasing at the same time. One last thing to remember, when we are moving from our acceleration graph to our velocity graph, or our velocity graph to our position graph, the starting value of the derivative graph does not necessarily determine that of its integral graph. Thanks for watching. Hopefully you learned something about graphing functions and their first and second derivatives.
If you like this video, please leave a like, comment, and subscribe.